Hello everybody and welcome to the last video of our linear algebra review, and in this video I'm going to introduce you to the world of matrices and vectors on Python. So I also wanted to introduce you to the TensorFlow framework, and this is the official website of the TensorFlow framework. And I want you to, because we're going to use it next in the next few videos, I want you to install it on your machine, and you can just go here, install, and choose according to your operating system uh, which version to install on Python. Also, you're gonna need, before installing TensorFlow, you're gonna need to install NumPy library, which is a mathematical operations library on Python. I'm using PyCharm uh, for development for programming, and but you can use uh, any development editor out there. By the way, in the when I installed first TensorFlow on Windows, on Linux I didn't have problems, but on Windows it was working only in Python 3.5. But I'm not sure, did they upgrade it or did they not? I'm not sure. So you should definitely check in the official website while installing it. And yeah, so let's first import the NumPy. We're not going to use TensorFlow for this video, so no need to import it. So let's start to introduce you to how to define a vector here. So it's straightforward, not like this is a vector. So it's exactly like you would write it in the real world. It's not like in R. So let's see what's the length of our vector. So 5. Okay, so how to create a matrix in Python? So in Python, a matrix is just a bunch of vectors that are stacked upon each other. And separated by a column. Oh, actually I wanted to print A. Okay, you can see here, actually this is not a vector. It might seem so, but it's not. It's a matrix, because you can see that here is a vector and it's separated by a column, and then a vector, and then separated by another column, and so on. So yeah, okay, so let's do some operations. For example, let's multiply the matrix by the vector using the NumPy library. Okay, so that's called NP. So there is two functions that look similar. The first one is multiply, which is this one, and there is this one actually is element-wise multiplication. So you multiply this by this, and then this by this, and then this by this. So it's element-wise multiplication, but that's not what we want. We want a matrix multiplication, which we studied in the previous videos. So yeah, how to do that? Mat like stands for matrix multiplication. So I hope it's obvious. Okay, we need to multiply a and y and print the result. So here is the result. We did the multiplication. Okay, so now let's create another matrix and do matrix multiplication. I am so lazy, so I'm just gonna copy paste and call it B. So as you noticed already, if we do a matrix multiplication like that, the second dimension here is 5, while the first dimension here is 3. So the multiplication not gonna work, and we're gonna have a cool error that the dimensions are not, the shapes or the dimensions are not aligned. So one solution for that is we already studied something called transpose. So we can transpose second matrix, which is B. So it's gonna become 3 5 5 3. So let's transpose B before doing the multiplication. So B becomes, using NumPy always, transpose transpose B. And now, since the shapes are okay together, so we can do the multiplication. Okay, one other thing, the inverse. We study the inverse. So let's see the inverse of A. There is one sublibrary called in the NumPy library called for stands for linear algebra. We can use that, and there is inv function which stands for inverse. Inverse A. Oh yeah, we didn't change. The last two dimensions of a ring must be square. Oh yeah, I forgot the simple rule. Here A is 3 by 5, so it's not square. So we cannot have an inverse for that. So let's try a 3 by 3 matrix. Let's turn it to a 3 by 3 matrix. Okay. We don't need any more to do this multiplication here. We want the inverse. So this is exactly what I wanted. So I told you that not all matrices have inverse. So even though the matrix is square and you guess that, okay, I think it has an inverse. No, not all have an inverse. And the matrices that do not have an inverse, they are called singular matrix. Singular matrix, remember the name. So a singular matrix is a matrix which does not have an inverse. So okay, so let's try the matrix we saw in our presentation here. 0 3 1 5 8 0 1 0 4. 0 3 1 5 8 0 1 0 4. Okay, now we're gonna have the inverse of the matrix. If we are right and all what we studied is right, we're gonna have to find out that the Python version of the inverse that we have is exactly as the same the R version. So let's see here, minus 0.47, 0.17, 0.11, minus 0.47, 0.17, 0.11. So we are right. So okay, so that's the inverse in Python. So now let's try to multiply the inverse with the matrix itself. We said that if you multiply the inverse with the matrix itself, we should have the identity matrix, if you remember. So you can see here we have 1 1 1 in the diagonal, zeros and zeros, and this is also 0 because it's like multiplied by 10 to the power of minus 17, which is almost 0. So yeah, we have the identity matrix. What if we inverse the order? Okay, we should have the same exact result. So let's see. We have 1, 1, 1 in the diagonal, zeros here, and this is also 0 to the multiplied by 10 to the power of minus 17, multiplied by 10 to the power of minus 17. So it's considered 0, 0, 0, 0. So yeah, so everything is well. So yeah, that was our Python introduction to the world of machine learning. We we didn't start machine learning. That's for the next chapter and the next video. So it's gonna be really cool, and from there starts the fun part. And now we have like an introduction how to define vectors and matrices and how to do some inverse transpose operations and so on. Use the NumPy library, which is really easy. You just need to import it and use it right away. So thank you very much and see you next video.